Alright, today we'll talk about function transformations. We talked about this in chapter 2, but it's been a while. So let's revise it. Let's say we have a function y is equal to x squared. This is a quadratic function, it's a parabola. Remember, f of x is x squared. That is y is equal to x squared. Now suppose we want to move the function up. So up. I won't use the formal terms. Up is basically translation along the y-axis. Well, to move a function up, if I have a function like this, and I want to move it up, well, I will simply add something. To the y-coordinate. So, if I have f of x is equal to x squared as the original function, so original, new function, the up function would be g of x is f of x plus something, so plus 4. Okay, so that means g of x is x squared plus 4. We are adding something to the y-coordinate. In the same way, if you subtract something from the y-coordinate, you will get a function going down. So I will say this is up or down. Okay. So for up or down, modify y-coordinate. Okay, that's kind of straightforward. So to move up or down, we are affecting the y-coordinate. Now suppose we want to move left and right. So left or right. Okay, so let's start with left first. So if I want to move the function left, so I have a function, and now the new function is somewhere there. Okay, so new function is somewhere there. Well, you can see the new function. If you can see the new function, f of x is x squared. The new function g of x, when we're moving left or right, we're affecting the x coordinate. Why? Well, if you notice, this function here, the new function, is going way up there. Here, say x was 1, and 1 squared is 1, right? But now, at x equals to 1, well, x is really far up there. That means x has grown a lot. How much has it grown? Well, if this is 4, because we've moved, sorry, it's negative 4. Now the new x would be x plus 4. Why? Well, now you can see x has grown tremendously here, right? Previously at x equals 1, the function y output was 1. But now at x equals 1, the output is really big. It's 25. How do we get 25? Well, I'm adding 4 to the x-coordinate. So when the function moves to the left, so when the function moves in that direction, to the left, well, the x-coordinate needs to increase, right? The x-coordinate needs to increase because the function itself has moved to the left, and now the x-coordinate has increased tremendously. And so the x-coordinate is affected when you move left to right. So left to right is in the x direction. The x-coordinate gets affected. In the same way, if we move to the right, so we have the original function, and now we have a new function, say somewhere there. Okay. Now, originally the function was f of x is x squared. What's the new function? The new function is, suppose this is at 4, we've moved 4 units, x minus 4. Why it's a minus? Well, when we move to the right, suppose we were somewhere here, and say at 5. Originally at 5, we were really high up there, right? Originally, this is the original function. We were at 25 for x is equal to 5. So the function output was 25. Now the new function is 1. So the new function output is really low. That means the x has to decrease because originally the function was 1 here, but now the function is 1 here. So you've affected the input. So x has to be decreased, so x minus 4. That's how the whole flipping the sign comes, because the right is positive, but you notice it is x minus 4. Because when you move the function to the right, you're kind of decreasing the x coordinate. I hope that's making sense. When you move to the left, you are increasing the x coordinate. Okay, so think about that. If your point was here and you move the function to the right, or to the left, sorry, you move the function to the left, now the x coordinate has increased, right? If the function moves to the right, the x coordinate is decreasing. So keep that in mind. Just visualize it on the x-axis. What about vertical stretch and horizontal stretch? So let's try vertical stretch, all right? Vertical stretch is pretty straightforward. So vertical stretch, I have a function, f of x is x squared, and now my new function g of x is, say, 4x squared. What's happening? Well, you notice if this is the original function, the new function is pushed away from the x-axis. Every y coordinate is suddenly increased, right? So suppose it was here, the y coordinate is here. So say it's 1 unit. Now suddenly the y coordinate is 4 units. So the y coordinate moves away from the x-axis. Okay, the y coordinate moves away from the x-axis, right? And the x coordinate, for the same x coordinate, the y coordinate moves away. In the same way, you can think of shrink. For shrink, I won't do that because the video will get long. For shrink, the y coordinate moves towards the x-axis. This number will be less than 1, say half or something. Horizontal stretch. Again, the horizontal one is a little confusing because the x coordinate gets affected. So f of x is x squared, and the new function is x divided by 2 the whole squared. Well, what happens? So if I have a function, what I'm saying is I'm purposely trying to compress the x. Okay, this is what's happening. What I'm saying is suppose I have some number 4 here. Okay, so originally at 4 I was up there at 16, right? Originally I was at 16. So that would be the output, 16, right? But now I'm purposely compressing it. I'm compressing the x value. So what I'm saying is for x equals 4, I instead divide the x by 2. So 4 divided by 2 is 2, and 2 squared is 4. So I'm taking the value from here and putting it there. So I'm taking the value for x equals 2 and I'm pushing it at x equals 4. So I'm taking the value from here and putting it there. So you can think of it as you're reducing the x coordinate to stretch it. I'm reducing the x coordinate to stretch it. And you notice my arrow is saying I'm moving the point away from the y-axis. So for the horizontal stretch, you are moving the point away from the y-axis. How? Well, you are changing the x coordinate. You're saying when I have a 4, I will take a 2. When I have a 6, I will take a 3. That way, this point from here will move there. So when I'm at 4, I'm taking the output of 2, the original output of 2, and so on. So this can be done for any function, right? So up and down, you basically add or subtract from the y coordinate. For vertical stretch or vertical shrink, you will multiply the y coordinate with some number. For horizontal translation, so left or right, you will change the x coordinate. Sorry, you will change the x coordinate for the horizontal stuff. And for the horizontal stretch and shrink, you will modify the x coordinate again. So I hope that made sense. Please talk to me during office hours if that did not make sense. I hope to see you soon.